1, 2, 3, 4. There's something happening here. Now what it is ain't exactly clear. There's a man without a mask over there. It's telling me that he just don't care. Think it's time we stop now, slow things down. Gotta turn this thing around. Battle lines are being drawn. No one knows what's right or what is wrong. Pent up and speaking their mind. Playing with our health now is just not fine. We gotta stop now, slow things down. Gotta turn this thing around. Gotta feel bad for the heat. People gotta work to eat. Free food sure sounds fine, but when you come, what you see is an 8-hour line. And I stop now, slow things down. We gotta turn this thing around. Stop, children, slow things down. We gotta turn this thing around. Stop now, what's that sound? Everybody look what's going round. Alright everyone, Mr. Pat from the Windward Boys and Girls Club. That was like a redo of there was a group in the 60s, kind of the first super group. If you follow any of that back, way back when, old guys music, and Steve Stills, Neil Young, Richie Furay, Jim Messina, the Buffalo Springfield. That was a protest song called For What It's Worth. And since there's so much protest stuff going on nowadays, I figured it was appropriate to sing something like that. Today's even crazier because people gotta work. They want to work above everything else, but then other people's health is jeopardized. So it's really tough decision. So try not to judge what people are doing. Just do the right thing yourself. You take care of yourself, and that'll take care of everybody else at the same time. Okay? Again, Kailua Windward Boys and Girls Club, Mr. Pat. I get off my soapbox right there and into the math lesson. So we're going to continue on with a quadratic function. I'll spin this and let you know what I'm talking about here. Okay, if you were with us yesterday, you got to get that centered. If you were with us yesterday, last lesson, you saw a different form of the equation. So if you look at this up here, what's different on this one is there's a plano x term. The one lesson ago had the squared and the plano number, but no more the x. So today we're going to see ones that look like this. I'll show you what I'm talking about. What we did the last time was something like this. Minus 2x squared plus 7. Okay, that's what you've seen. So today, I'll do this in a different color. We're going to add the middle term here. So this is the quadratic, this is the constant, they call it. So let's say I had same thing there, And same thing there, but this time maybe I'll add that, and that's the linear term. So that thing right there is what makes this equation different than this. And we used a table for all these top ones. That's the correct way to do it. This is going to be something entirely different. You're going to learn a weird formula, ABC values, all these things. All right, so I'm going to erase that. And over on the left here in the green axis, these are the parts of what we're going to be doing to create our graph today. So these are parabolic functions, the parabolas, the u. They might go right side up, they might go pointing down. So they're going to have a middle of them that separates it into mirror images called the axis of symmetry. You're going to be finding that. So here, if you look at this, -1, -2 on the x-axis, the axis of symmetry here is x equals -2. It's a vertical axis cutting the parabola in half. The other part is the vertex. That's a very important part. It's either the very bottom, if it's one that points up, or if it points down, opens up down, it'll be the very top. And you're going to have a coordinates, ordered pair. So this one you go 1, 2 over. So the vertex is -2, and then 1, 2, 3, 4 down. So the vertex of this equation is -2, -4. And the last thing we're going to find today is the y-intercept, where this parabola crosses the y-axis. It's going to be a single point if there is one. Not all of them will have the same thing. So this is at -1, so the y-intercept is -1. Okay. And in coming lessons, we'll teach about the x-intercepts. For now, we're going to be looking for the axis of symmetry, the vertex, and the y-intercept. Okay, so what we're going to do is get you going on a problem. So I'm going to erase this. Okay. So for example 1, there's nothing like getting started at the beginning, but I got to show you the formula you're going to be using and how to use it. I'll write the formula right here. It's -b over 2a. X equals that. And you're like going, what? What's a? What's b? Well, that's the first thing I'm going to show you. The a, b, and c values come from the equation themselves. So, for example, we're not going to graph this. This just shows you how to use it. Let's say I had y equals 3x squared, okay, ready, minus, let's see, 18x plus 5. So the a, b, and c values, you're going to be listing them on each problem and then using them. The a value is the coefficient of the x squared, the quadratic. So whatever number is multiplying times x squared is your a value. The b value is the coefficient of the plain old x. Gotta be careful here. It's not 18, it's -18. And the c value is this plain old constant number. So we're going to use those to do our graph. So the way we would use it is we go into that formula. So this says -b over 2a. Okay? So x equals, now here's what we do. Look at b. b is -18 already. So that's part of this number. That's part of the formula. So you go like this to do this, right? Put the b inside the parentheses. Then you go 2 times whatever a is. So negative, the opposite of negative 18 is positive 18. 2 times 3 is 6. So x equals 18 over 6 or 3. That's what we're going to do. So you're going to have the equation. You want to make sure y is by itself. I'll tell you more about that in a minute. You pull the a, b, and c values and write them down. You carefully go into this formula and get a number. Then I'll show you what to do with it. Okay? So let's do a real example that we's going to graph. Okay, ladies and gentlemen, here we go. Example number 1. Whoops, don't do that, Mr. Kent. Y equals, as soon as you see that, that's a good thing because y is all by itself. 3x squared minus 6x plus 2. So let's come over here and do A, B, C. You should do this on your own if you're not sure. Okay? The number multiplying times x squared is positive 3. Yay. Careful here, that's 6x, but it's minus 6x, so it's negative 6, and that's 2. Okay, got it? Okay, we're going to go into our formula. X equals negative b over 2a. Okay, so x equals negative, make sure you get the right one, negative 6. A is 3. So x equals, the opposite of negative 6 is positive 6. 2 times 3 is 6. Look at that. In this case, it's 1. So that's a huge bit of information. So you got x equals 1. That's what we need. So here's what that tells you. It tells you a couple different things. Okay. Once you get x is 1, that tells you the axis of symmetry. I'll abbreviate it. Is x equals 1. So if you look back to the start, that means we can draw a line here at positive 1. I recommend to my students they use a straight edge and they make a dashed line. Okay, there's your line of symmetry. That's the middle of your parabola. Okay. The other thing that this finds, it finds not the whole vertex, but it finds the x coordinate. So this number right here is the axis of symmetry, and it's the x coordinate of the vertex. You still have to find the y coordinate. Okay, so I'm going to show you how to do that now. So I had my equation, I had y by itself, I wrote my a, b, and c values down. I plugged into my formula carefully and got my x value. That tells me the line of, the axis of symmetry. Call it the line of symmetry if you want. And it tells me the x-coordinate of the vertex. Okay. So now what I do is I need this y-coordinate. And here's how you do it. You look back up here, and there's your y. I don't know what it is, but I know what x is already. X is 1. I'm looking for the y value. It's just like a t-chart when x is 1. So I'm putting 1 here for the x. So I got 3 times 1 squared minus 6 times 1 plus 2. All right, so I put a 1 wherever the x is, because that's the x value. 1 squared is 1, so that's y equals 3 times 1 is 3. 6 times 1 is 6 plus 2. Do your arithmetic carefully. 3 minus 6 is negative 3, plus 2 is negative 1. So when x is 1, y is negative 1. Awesome. So that's my vertex. Positive 1, negative 1, right there. Okay, I need one more thing. It's the y-intercept. All right, I'm going to erase this. The y-intercept is not the y we just found. That was the vertex coordinate. The y-intercept is, where is this going to cross the y-axis? It's actually extremely easy. Every point on the y-axis, you don't go right, you don't go left. So x is 0. If you look back at the x and y-intercept lesson, you're going to remember that. Every single y-intercept, the x value is 0. Every y-intercept, the x value is 0. So what will y be if we put x equaling 0? This is how you do algebra, folks. 0 squared, 0. 3 times 0 is 0. 6 times 0 is 0. Nothing minus nothing is nothing, so y equals 2. That's my y-intercept. Bam! Okay. Now, what's cool about this is that's going to happen every single time. Every single y-intercept, x is going to be 0, so these two terms will disappear. So what we learn is the c value is your y-intercept. That's all you got to do. So I go like this, I put 2. Now this is the axis of symmetry. It reflects over. If it's 1 away here, it has to be 1 here. And that's enough to draw your graph if you want. Maybe that's not enough for you. A lot of people will do another point. I want to show you how to do that. You could just go straight from there, though. No one would mark you wrong. Okay, check this out. And what if we put x is 2 in? What if I want to know, okay, that's going to be right there. How about x is 3? Let's do that one. Let's see if it'll work. I got 2 here. It's 2, 2. So if I put an x is 3, I'm looking for an extra point here. So check this out. Y equals 3 times 3 squared minus 6 times 3 plus 2. 3 squared is 9. 3 times 9 is 27. 6 times 3 is 18 plus 2. 27 minus 18 is 9 plus 2, so y will equal 11. So what I'm doing is an extra step to give me a better picture of how this opens or closes. So I chose this x being 3 plugged in here and saw what Y came out. So if I go 3 over, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I go 3 over, and up here, that gives me a point. And I can reflect it over on this side, the same thing. And make sure I did that right. So I'm 2 to this side, so I gotta be 2 to this side, right around there. Okay, now if I connect that, you're gonna laugh. That's the hardest part sometimes, is connecting and drawing a parabola. Okay, but that's it. So you did well. You did all the parts. Okay, that's awesome. It's a very complicated thing. You can wind back the lesson, check it over and over and over. We're going to do it again tomorrow, just straight up practice. We'll go through the whole thing again. Okay, I want to thank you for everything. Hope you enjoy the music too. It's one of those things where I'm just trying to keep it loose, keep it happy. It's a very tricky time right now. We all got to take care of each other, so take care of yourself, take care of your parents, take care of your friends. Okay, that's all we can do, each of us. Complete that 311. If I was working on paper, I'd make these look a little neater, but you get the picture. Okay, thank you. Thanks to the Buffalo Springfield for the song For What It's Worth. And Mr. Pat, Windward Boys and Girls Club, reaching out to you. Aloha. We care about you. We're looking forward to seeing you again soon. Aloha.